Today's featured speaker is Kat Traxler. She's a security professional. If during the webcast you have any questions for our presenter, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Kat.
Thanks so much, Carol, for the intro, and quick thank you to everybody who took some time out in their day to learn about GCP privilege escalation. I know that there's a lot of other things you could be doing today, but you're choosing to spend it with me, and I really appreciate that. A little bit about me before we get started. I came into security with a development background. And naturally, that led me to being really interested in web application security, especially JavaScript and front-end technologies, Web 2.0. I've also spent a lot of time working on cloud security platforms, and the security of AWS and GCP, which is a topic of today's webcast. And when I'm not doing security things, I like to kind of cosplay as a farmer in my suburban garden. So to give you all an idea of what we're going to cover today, hopefully this will clock in right around 40 minutes, and then I can give everybody a chance to ask as many questions as they want, and I'll get to as many as I can. First up, I want to level set everybody on Google Cloud Platform, specifically about identity and access management on Google Platform. We're going to talk a little bit about the resource hierarchy, how that influences inheritance on the platform. We'll talk a little bit about service accounts on Google Cloud Platform, and why they are both identities and resources. So for the next 15 minutes, let's just cover some groundwork and I'll level set. The most important thing in any identity and access management platform is to understand how we grant permissions. In the Google platform, it is a three-part construct. There is the who, there is the what permissions, what role, and then those two items create a policy binding, and they are attached to a resource. The who in Google Cloud Platform are members. Members of a policy are any identity. We'll cover that a little bit more when we dig more into the different identity types. And roles are collection of permissions. Not unlike AWS with their managed policies, GCP provides you with a set of custom or sort of customer managed roles. So Google Cloud Platform will manage a collection of permissions that provides you permissions to perform certain job functions. When you marry the who, the identity, and the role, you get your policy binding, and then you want to apply it to a resource and say Bob can access cloud buckets in this project. Unlike AWS, GCP is organized in a hierarchical fashion, with the top level node being the organization. Beyond that, you can create folders to organize your projects into. And then under a project is your collection of resources. Things we all know and love, like cloud compute, cloud storage, PubSub, all of those little widgets that make up the stuff. All of those are classified as the lowest level in the hierarchy, and they all have one direct parent, which is a project. Interesting enough to note that each one of these layers in the hierarchy, the organization, the folder, the project, the resources, each one of these is considered a resource by Google Cloud Platform. And each one of these are notably IAM identity attachment points. So you can apply policy at the organization level. You can apply policy at folder level. You can classically apply policy at a project or specifically on a resource. You can say Bob has access to view the objects in a storage bucket, but only this specific storage bucket. So that would be an example of applying policy to a resource. And I also like to point out that when applying IAM policy, there is inheritance that trickles down. So in my example here, we have Bob in accounting, who is a viewer at the organization level. Bob's able to view all of the metadata, all of the information in that org, all the way down from the organization, folders, projects, and all the resources. Bob can also be an editor at the project level and have all of the collection of permissions associated with the primitive editor role, but only at a specific project level, and that will then trickle down into the resources that are owned by that project. So I would certainly expect that any users or any identities to have multiple bindings throughout your organization. And there's a few different types of identities that can be members in a policy. We can apply permissions to users. These are just members of your domain, your G Suite domain. Same with groups. Groups are just collections of users. Those are defined in G Suite, and you probably want as a good practice to place users into groups and then apply roles to the groups in Google Cloud Platform, as opposed to applying roles directly to the users. There's also a newer construct called the namespace identity. What a namespace identity is, it's a member in your policy, which you can apply a role to, like all of the other identities. But what it does is it uniquely identifies a Kubernetes service account and namespace. So it's used to externalize what is otherwise a Kubernetes native construct, which is a service account in Kubernetes, and it externalizes that identity into GCP, so we can do things like make it a member in a binding and apply roles. Where we're really going to be focusing today is service accounts. Service accounts are those non-human entities. You're going to have service accounts created for automation. You're going to have service accounts created as identities to your infrastructure. Everything in Google Cloud Platform needs to have an identity to establish trust. And when it's not a user and it's not a group, you're going to have to create a service account for that. And we can think of service accounts in like two big broad buckets and reason about them totally separately. The Google managed service accounts are service accounts that are owned by Google. You're going to see these in your projects with IAM role bindings, policy bindings. So if you're going to have permissions within your project, whenever you enable an API on Google Cloud Platform, these Google managed service accounts are created in order to facilitate trust between your project and that API. But we can reason about these differently for a few reasons. You can't generate keys from a Google managed service account. You can't impersonate that service account. So while they tend to be highly privileged and there is some risk associated with Google managed service accounts, for the purposes of this talk where we're talking about impersonation, we can really set Google managed service accounts aside and focus strictly on the customer managed service accounts. Customer managed service accounts are owned by you. They actually might be created on your behalf though, when you're spinning up a cloud compute. Google might create a customer managed service account on your behalf to serve as the identity for that compute instance. But they're wholly owned by you, and they live as resources within your project. You can generate keys for these customer managed service accounts. You can impersonate them. You can act as them. You could otherwise operate them. So these are resources within your project that are fully within your control. Service accounts are resources, like any of the other resources within your project. Underneath the project, you can create cloud buckets, and you can define a policy on that bucket, or cloud compute, indicate who can operate that cloud compute in various ways. Pub sub, the same. There's various ways you can set policy on a pub sub, on its topic, or to subscribe to it. Service accounts are no different. They have a unique set of permissions that only apply to service accounts. And that's what we're going to be focusing on today, is the set of permissions that allows one to operate a service account. To drive the point home about service accounts as identities and resources, I'd like to give the example that you could have a situation where service account A is allowed to operate service account B. So service account A is a member in a policy that has a role. That role allows it to operate service account B, and it's attached to service account B. So in this case, service account A is your identity, has the role, and service account B is the resource, because it's the one that has the IAM policy attached to it. I'm glad you all stayed with me on that groundwork of learning about IAM. There's more on service accounts to learn. We're going to get even deeper into service accounts. We're going to talk a little bit more about what it means to operate a service account. And I think it's important to know what are the roles that allow you to operate a service account. And then what are the implications of applying those roles at different levels of the resource hierarchy. You can operate on a service account in several different fashions, and I've segmented it out into 3 different big buckets. Impersonation, act as, or creating keys. With these 3 buckets of IAM policy, one can utilize the grants or utilize the permissions associated with a service account. Interestingly enough, there is no permission in Google Cloud Platform called Impersonate. Instead, there is a collection of 4 permissions, any one of which would allow for impersonation. Those permissions are to get an access token, the permission to get an access token, the permission to get an ID token, the permission to sign a JOT, or the permission to sign an ID token. Any one of those permissions would allow the member in the policy to generate a short-lived access token for a service account. And the ability to impersonate and act as and create keys are sort of scattered throughout various roles. Classically, we think of impersonation being contained within the service account token creator role. That role is a collection of permissions that allows the bearer to impersonate a service account. The same permissions or the same ability is also contained within the workload identity user. That role by convention is really only ever assigned to namespace, identity namespaces. We also have these service agent roles that have the ability to impersonate a service account. By convention, these service agent roles, you're only going to see them assigned to those Google managed service accounts. So I'd like to mention them here so we don't forget about them, and so you know where these permissions, what roles these permissions lie in. But for the purpose of this talk, these service agent roles, in the wild, you're not going to see them applied to anything other than a Google managed service account. So we can sort of set those aside. I want to really harpen on the editor role, though. The editor role I have highlighted. It's a role that contains the permissions to both act as a service account and create keys for a service account. So what is act as? Act as is the ability to act through a service account. It's the required permission for when you need to assign an identity to a piece of infrastructure. Take the example of cloud compute. If you need to create a cloud compute, you have the permission to create a cloud compute. And then you need to assign that cloud compute an identity. You need to have the permission to act as that identity in order to assign the service account to the compute. The service account token creator role is the role, as I mentioned, that has a series of permissions, any one of which allows you to impersonate another service account. And when we apply that role at, say, the project level, the implication that that has is that any member who has that role at the project level is then allowed to operate on, is allowed to impersonate any of the service accounts contained as a resource within that project. I have a quick walkthrough of a demo. I want to show you some of the implications of assigning the service account token creator role. The implications specifically around assigning that role at a project level. Yep, we're going to walk through that demo about assigning the service account token creator role at the project level. And then we're going to take some learnings, hopefully, from that. And then we're going to assign that same role, that service account token creator role, but we're going to assign it at the service account level. So same role, just applied at two different levels of the resource hierarchy. So first off, let's take a look at the active accounts that I have. Here I'm using G-Cloud, which is the command line interface for interacting with Google Cloud Compute. And I'm simply saying G-Cloud auth list to list out the users that I have authenticated. I have a couple different users, tester 1 and tester 2. Let's go ahead and use tester 1, and let's list out the projects that are available to me. Right, I have the classically named my first project. So we have one project available to us. Using that name of that project, I'm going to go ahead and say G-Cloud lists out the service accounts that are available in that project. And as you notice here, we have 3 different service accounts listed. We have the Compute Engine default service account that was created for us. Google created that on our behalfs, but it is a service account that we own. And that I own is that in my project. There's a couple other service accounts that are handily named. One is a privileged service account, and one is a less privileged service account. I'm going to go ahead now and I'm going to say, what is the IAM policy attached to those service accounts? Is there any policy directly attached to them? So G-Cloud IAM service accounts get IAM policy. Get IAM policy for the less privileged service account and the privileged service account. And as we can see, there is no IAM policy set on those resources. All right, let's take it a step up and let's go to the project level. And let's list out what the IAM policy is at the project level. We have a few different bindings. We have a few different members with roles. The first chunk here is listing out who all is editor. It looks like we have our less privileged service account is editor, our privileged service account is editor, even our default service account for compute is editor. Moving down, we've got 3 different owners of this project. That privileged service account is owner. Also, the first tester user that I'm using, tester 1, is also an owner. And we have the project IAM admin. As you can imagine, that's a fairly privileged role, and that would be a juicy target for anybody wanting to escalate their privileges to identify a service account that has the project IAM role. So I'm going to go ahead and I'm going to act on our objective here, which is to create some policy. We're going to apply policy at the project level. And what we're going to say is tester number 2, who is just a viewer, as you can see. Tester number 2 is going to get an additional policy. Tester number 2 is going to have the service account token creator role assigned at the project level. This role is going to allow for impersonation, and we're going to apply it at the project level. I'm going to switch over to that tester 2, and I'm going to use those newfound privileges. Let's list out again what the service accounts are. We have our less privileged service account, we have our privileged service account, and then we have the default one. So as tester number 2, I now have the ability to impersonate any of these service accounts. And once you know it, that I'm going to choose to impersonate this privileged service account. If we remember correctly, that privileged service account is owner at the project level. It's also project IAM admin. So it'd be dumb not to, right? Let's go ahead and just to prove that we can impersonate that service account, as tester 2, I'm going to say print out the access token for the privileged service account. Print out the access token and also impersonate the privileged service account. You have to indicate that you're impersonating it, the service account, to print out the appropriate access token. So there we go. We have an access token for our privileged service account. As a reminder, that privileged service account was in project owner, project IAM admin, and editor. So we moved from viewer to project owner, just as a result of setting the service account token creator role at the project level. Google's not going to ever recommend that you set these types of roles at the project level. It's just not a good practice. In fact, what you want to do is you want to set roles at the lowest level possible. So in our resource hierarchy, we have an org, we have potentially folders, projects, and then a collection of resources. And in any IAM policy that you set, you're going to want to set it at that lowest level of the resource hierarchy possible. In our example, when we want to enable our tester 2 to impersonate a service account, we need to apply the policy on the service account level and not at the project level. As we saw in the last walkthrough, that allowed for the user to impersonate any service account that was a resource and also any future service account that may be created in that project. So what we're going to go ahead and do is we're going to assign the service account token creator role directly to the service account that we want to enable it to impersonate. In this case, it's going to be a project editor. As I mentioned previously, the project editor has the permission to act as. This is going to give the ability to create a VM and then attach an identity to that VM. So let's take a look at the conditions we're setting up for when we assign the service account token creator role directly to the resource. Same couple users, tester 1 and tester 2, and same project, my first project. Same handful of service accounts. What I've gone ahead and I've done is I've removed that project level role that we saw in the previous walkthrough, and I've changed it, and I've said instead of having the service account token creator role set at the project level, let's set it directly on the less privileged service account. So as you see here, G-Cloud IAM service accounts, get IAM policy, less privileged service account. And here we see what that binding is at the service account level. Tester 2 can create a token for that service account. It can impersonate the less privileged service account, no other service account. So let's remind ourselves what the permissions are, what the policy is at the project level. We have our less privileged service account is an editor. And that is the service account that we're allowed to impersonate. Switch over to that second tester. That's the one that we've enabled impersonation for. And let's prove that this works. We're going to go ahead and we're going to print the access token for the less privileged service account, and we're going to print the identity token for the less privileged service account. We print those tokens, and then we also impersonate the service account. Hang with me while we update our local access token database. When you're using G-Cloud, when you're using their CLI tools, there's a local cache of all of your tokens, short-term tokens, long-term tokens. The access token database contains your access token, which lasts for 1 hour, and your identity token. What I'm doing here is I'm updating my local cache of access tokens, and I am replacing it with the access tokens that I printed out for the less privileged service accounts. So now as I run commands from here on out as tester 2, my G-Cloud CLI is just going to use the access tokens for less privileged service accounts, for less privileged service account. Now that I've made that slight modification to my access token database, I don't have to tell G-Cloud that I'm impersonating the less privileged service account. It's just going to use the correct token. So I can say, I can create a compute instance. I'm going to go ahead as tester number 2, I'm going to say create a compute instance. And when you create that compute instance, it needs an identity. And I'm going to go ahead and say, assign an identity to that compute instance and assign it the privileged service account that lives in my project. You can assign any service account that lives in your project to the newly created compute instance. So that's what we're going to do. So as you can see, it's successful. We have a new compute instance stood up. And since I created that compute, I can go ahead and SSH into the compute. So I'm going to SSH into the compute instance as less privileged service account for which I have tokens for. Now that I'm local on the compute instance, I have available to me the metadata API. This is an internal API that comes built in with quite a few pieces of infrastructure on all different cloud platforms. It allows for local queries and to tell you about information about that infrastructure. In this case, I'm going to go ahead and I'm going to say metadata API, please return me the access token for the identity which you're running as. You're running as the privileged service account, so please give me that token. So as you can see here, we have the access token now from the privileged service account. Oh, what just happened? Well, we took one role binding, which was the service account token creator. That role allowed you to impersonate an editor. Editor has the privilege to act as. Within that account, within that project, there was another service account that had even higher permissions. It was an owner. So because I can act as, I can act through all other service accounts and through the creation of infrastructure and assigning identities. I would be remiss if I didn't give everybody some context around why these conditions occur and what you can do about them. So for our next chunk, we're going to talk about mitigation. We're going to say, how did these dangerous conditions occur? How did these privilege escalation paths occur? And is there any way of designing around them? Is there any way to kind of cut off the privilege escalation or lateral movement paths of an attacker? And there's a couple things to consider when we have a dangerous condition occur, like privilege escalation by impersonation or privilege escalation by ACTAS. There's two different things colliding in your project. One, you have service accounts, which are resources, co-mingling in the same project that you have other IAM role bindings. So on the left here, I'm displaying that we have one project that contains our service accounts and another project that have a collection of IAM role bindings. Users will have whatever permissions are necessary, but they're not going to commingle with your service accounts. Another way to think about this is to prevent those permissions from occurring in the first place. As I mentioned, there's a handful of roles within Google Cloud Platform that are going to allow for this type of privilege escalation, specifically privilege escalation through a service account. I mentioned that the editor role has the act as permission, service account token creator, service account user. These roles, when assigned to any identity and they commingle with a service account as a resource, those are the two conditions that create those pathways. A really great pattern to think about is segmenting off your transitive paths. A good thing to think about is to segment off those service accounts into their own project. This proposal cordons off all of those dangerous transitive paths into their own bubble, and it really limits what IAM role bindings commingle in that same project. You might have IAM role bindings that are inherited down from your organization. Ideally, those are really highly trusted individuals or groups. You might also have a service account with an IAM role binding that is used for automation to automate the creation of these service accounts. But by and large, you're going to keep bottom from accounting out of this project. You're going to keep all of your workaday users who just need to work on the platform out of this project. And how you enable the other projects to use service accounts like they will need to is you create these cross-project bindings. So that when your service accounts are cordoned off, they don't have any permissions in their cordoned off project. Instead, they have roles into all of the other projects as needed. So in an ideal situation, you have some automation, or you have some self-service project where you have teams working in projects and they can request service accounts, and you can pipe that through your change management process and put governance around that. And then you can have all of your service accounts emanate from a single project and can make the connections via IAM role bindings. This pattern has a lot of benefits in that you can be a little less strict with some of the permissions, some of the dangerous permissions that allow for impersonation. If there are no service accounts to impersonate, then some of these roles really aren't so dangerous. If only we could continue that pattern or maintain that pattern throughout all service accounts. Because unfortunately, the pattern of cordoning off service accounts in one project and having no service accounts commingle, it can't be a be all and end all solution, because there's still circumstances where the service account needs to live in the same project as your resource. Take, for example, compute. I know I keep bringing that up, but compute needs an identity to function, and that identity needs to live in the same project as the compute resource. It can't be assigned an identity cross-project. So you're still going to have a couple of these circumstances where you're going to have a service account that commingles with Bob from accounting and Joe from operations. But hopefully the goal is you can limit it down to as few service accounts as possible. What service accounts do live in your project? Hopefully you can scope down the permissions so that you can really limit the lateral movement and privilege escalation paths on the ones that have to live in your projects. If there's anything you remember from this talk, please, I hope it is that the GCP resource hierarchy is omnipresent, and it is a critical piece of the platform to understand when attaching IAM policy. Where you apply that policy makes all the difference. Policy is inherited downwards through the stack, downwards from the organization level at the top node and all the way down to your little widgets, to your pub subs and your computes. Service accounts are both identities and resources. This presents a unique challenge, especially when you're looking at assigning roles to service accounts. The ability to impersonate a service account and act as a service account, those are your privilege escalation paths via a service account. Identify those in your project and strip them out of your project as much as possible. Also strip out of your projects the service accounts that don't need to be there. Whenever you can have a service account operate cross-project, that's going to be the path you want to go for. You want to go for a centralized model. And plain old just not assigning these roles wherever humanly possible. Please go ahead and take a hard look at the permissions containing within the editor roles, the owner roles, the service account token creator roles, and the service account user roles. I'd be remiss if I didn't give a few shout outs. As of 6 months ago, the field of GCP security research was pretty paltry. And as of just this spring, we've had an explosion of great research, talks, papers, tools come out. I'm just going to list a few folks here so you can follow up with these people and see the work that they've done. Chris Moberly, he put out a fantastic tutorial on privilege escalation in Google Cloud Platform, came out in February. If anybody ever talks to me about, asks me if they want to know more about Google Cloud Platform, IAM, and privilege escalation, I say, read Chris's blog. That is the start here. Spencer Geetson, you all may know and love him from his work on AWS privilege escalation. He's now pointed his skills to Google Cloud Platform. In the last couple of weeks, he's put out a series of blog posts outlining dangerous permissions within the platform and what type of escalation you can occur with the various permissions. It's also a collection of Python scripts he put out, just really fantastic tools for anybody looking to get into the space. Dylan and Allison, Dylan A-Ray, hope I'm pronouncing that, probably butchering that, and Allison Donovan, the two of them co-hosted a talk at B-Side San Francisco this year on attacking and defending the GCP metadata API. There's also an accompanied, I think, GitHub gist. If you want to learn more about the dangers of the metadata API, please watch their talk and read the accompanied post. If you want to know more about some of the inherent risks to those Google managed service accounts, the ones I sort of said we're going to set aside for today, if you want to learn more about what inherent risks there are around the Google managed service accounts, watch their talk. It's fantastic. And of course, Eric Johnson. Thank you so much, Eric, for gently nudging me to put this together. I don't think I would have done it without you just saying, hey, you should do that. So I really appreciate it. And with that, I'm gonna take some questions. See here, I apologize. I'm gonna have to exit out of Keynote in order for me to have a cursor back. So let's see what questions may have popped up. Okay, we have a question from Brandon Evans. Question is, why do you think GCP still utilizes primitive roles like editor by default for so much of its infrastructure? It seems like they're setting a bad example. That was a teed up question if I ever saw one. Of course it's awful. Just to give the folks at home an idea, there's various types of infrastructure that when you spin it up on Google Cloud Platform, a default identity is created for that, and the editor role is assigned by default. If you read the Google documentation, they recommend do not use the editor role, please change it. In fact, there's also an org policy which will block that default editor role, and yet it persists. I don't have a good answer for you. Well, you'll have to take that up with your Google TAM. I'm sure they've heard it, but it doesn't hurt to hear it more. No, it's a highly overprivileged role that's just assigned by default, and it's going to create a lot of dangerous conditions within projects if you're not careful about it. Okay, we've got another question here. Kat, what are your thoughts? What thoughts do you have on how VPC-SC might impact the ability to share service accounts across projects? VPC-SC, you're catching me on this. I don't know what a VPC-SC is, Jeff. I apologize. There's shared VPCs, but honestly, networking is not my strong suit. Generally speaking, IAM operates outside of that networking layer. So my understanding is that the only limitation from the hub and spoke pattern is there are certain Google APIs that require that when you're consuming that API, the identity that consumes it needs to be in the same project. And that's the issue with compute. I wouldn't think that any decisions around VPCs would impact that at all. But please somebody chime in and correct me if I got that wrong. Got another question here. Is there any way I can use identity policies and service accounts to ensure that any container that gets spun up in GCP has twist lock Prisma? Again, that's going to be out of my realm of expertise. However, I would assume not. What you're asking is to use a GCP policy to ensure a container has this vendor product twist lock Prisma. And that certainly wouldn't be a capability within Cloud IAM. That's certainly not a capability within your org policies. There's probably other ways you can have assurances around that through your like automation and then just like, you know, trust but verify kind of plans, but not in IAM, not in Cloud IAM. Would you be able to ensure that? VPC service controls, Jeff just chimed in. Okay, so let's see here. Jeff's original question was, what are your thoughts on how VPC service controls might impact the ability to share service accounts across project? VPC service controls, check them out with perimeters and bridges and accesses and levels. Yeah, that's TBD, VPC service controls. If you're gonna kind of firewall off the APIs in a VPC, that's from a Cloud IAM perspective, not firewall in a networking sense, but firewall in a Cloud IAM sense. How would that affect your ability to then do this cross-project pattern? I think it would probably inhibit it. That'd be my guess. Really good question, Jeff. I think with that, I think I'm going to end the broadcast. I really appreciate everybody for taking the time out of your day to listen. And if you have any other questions, please hit me up on Twitter. Thanks, folks.
All right, thank you so much, Kat, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.